All right, grade 8. It does seem like some of you are battling from this unit 7 and 9 with the equation. So I'm just going to talk you through some of it. So just to talk about what an equation is. An equation is a type of sum in maths that has an equal sign. Equation. So you have a left-hand side and a right-hand side. And your aim is to get the chosen letter, the variable. Normally it's x, but it doesn't always have to be x. But you've got to get the variable, the letter by itself, and get an answer for it. And you can always check by putting that answer back into the question and seeing that your left-hand side does equal your right-hand side. So our job is to try and get the letter, the variable by itself. Right, so solving equations with multiplication involved. Right, so when we are working with these solving equations, we've got to look at what we call the inverse, the opposite. So if we're going to be solving equations with multiplication in it, we're going to have to use division to undo it and get the letter by itself. Let me show you what that means. So it says if there is a coefficient is a number that is in front of the letter. So a coefficient with x, you need to get it alone. So you divide by that coefficient. So in this case, we have 4x equals 16. I want x by itself. So I need to undo multiplication, and so I divide. But an equation is very sensitive, and maths is very sensitive. You can't just do what you want wherever you want to. You have to balance it out. So we talk about what you do to one side, you always do to the other. It keeps the balance in place. All right, so if I divide on the one side, on the left side in this case, I must divide by 4 on the right-hand side. And so if we divide by 4 on the left, my 4's will cancel. 4 divided by 4 is 1. So there's an invisible 1. Remember our invisible maths? Invisible 1 in front of that x. And then 16 divided by 4 is 4. So we have now got x equal to 4. Now think about the original question. The original question was saying to you, 4 times x. Remember, when numbers are right next to letters, it means multiply. 4 times x equals 16. It means 4 times something gets me 16. That something must be 4. Now, in order to set it out properly, you can't just guess or look by inspection. You have to show us your steps. So let's quickly have a look at these few here. So 4x equals to 8. I need to get x by itself. It's currently being multiplied by 4, so I'm going to divide both sides by 4. Let's do it in the next step. So 4 divided by 4 is 1. X stays by itself because there is no other x's to work with. So we just look at the numbers. So we look at the 4 and the 4. All right, 8 divided by 4 is equal to 2. So it's saying x is equal to 2. Go back to the question and think. 4 times something gives me 8. 4 times 2 equals 8. So let's try with this one now. 10x equals to 30. So 10x equals 30. We need to get rid of the 10. It's being multiplied to the x. So I'm going to divide it by 10 to get the x by itself. So if I'm multiplying, I've got to divide to undo it. 30 divided by 10 is 3. The 10s cancel out. And then again, check. 10 times something equals 30. 10 times 3. That's something that x must be 3. Then we have negative 2x equal to 10. So I've got a negative 2 in front of my x, so I've got to divide both sides by negative 2. So my negative 2's go away, and I'm left with 10 divided by 2 is 5. Positive divided by negative is negative. Then negative 5a equals to negative 35. So I need to divide by negative 5 to get the letter by itself, the variable. In this case, it's a. But I can't just do it to one side. I've got to do it to the other. So negative 5 and negative 5 cancel out. Negative divided by negative is a positive. 35 divided by 5 is 7. So A is equal to positive 7. All right, and again, check yourself. Negative 5 times positive 7 will give you negative 35. A few more. 3 times x equals 7. So now this one's a bit harder because you can't imagine what the answer is going to be. So you have to show it. So 3x, x is being multiplied by 3, so I've got to divide it by 3 on both sides. So x is 7 over 3. So in this case, you can leave it as a fraction in that way. If I put it back in, 3 times 7 over 3, the 3's would cancel, and it would be just 7 over 1, which is 7. So it does work out. All right, and then this one looks a little bit weird because it's the opposite way. It doesn't matter which side your x is on. It still shows you once you get x by yourself what it's equal to. So at the moment, I have 20 equal to 4 times something. So to get my something by itself, I'm going to divide by 4 on both sides. So my 4's cancel. My x is by itself now. 20 divided by 4 is 5. So you can leave it written like that, or you can rearrange it as x equals 5. Right, so 5 equals x, or x equals 5. It means the same thing. Then negative x equals 9. Now that's a negative 1x equals 9. So I'm going to divide by negative 1 on both sides. That cancels. I'm going to have x by itself. 9 divided by 1 is 9. Positive divided by negative is negative. Then negative y equals negative 6. So that's negative 1y equals negative 6. I can divide out, because I'm trying to get y by itself, so I undo multiplication by dividing, but I've got to do it on the other side to keep the mathematical balance. So y is equal by itself. Negative over negative is positive. 6 divided by 1 is 6. Moving on now to solving with addition and subtraction. So when you have something added or subtracted with a letter, with a variable like x, you need to undo that addition or subtraction, but on the other side of the equation to balance it out. So in this case, for this first one here, it's negative 5 plus x. To get x by itself, I would need to take that over the equal sign. And the reason that I'm doing that is to get x by itself. And when we do that, the sign changes to a plus 5. So let's just go through what has happened here. So how would I undo subtraction? I would add. So negative 5 plus 5 would give me 0, so my x would be the same. But I can't just randomly add 5 onto one side of an equation. I've got to add it onto the other to balance it out. But then on the left, we're left with just x because the 5's cancel. And then we have 6 plus 5 is 11. So we're not just randomly taking the numbers over to the other side. It's part of doing the opposite operation, the inverse operation, to get x or whichever letter by itself. All right, so, and then it says the sign in front of a number or variable belongs to that number or variable. So that negative in front of that 5 belonged to that 5. Okay, so I'm going to do the long method for the first few, and then we'll just do the shortcut method after that. So x plus 3 equals to 9. I'm going to say, well, x has 3 being added to it. So how do I get rid of an addition of 3? I subtract 3. But I can't just do it to one side. I have to do it to both sides to keep the balance. It's like a set of scales where you have a left and right, like hanging piece. You've got to keep the balance. If you add something to one side, the scale's going to be out of whack, out of balance. So you've got to undo it on the other side. All right, so I can cancel my 3's there. Positive 3 minus 3 is equal to 0. So I've just got x there plus 0. And then 9 minus 3 is 6. All right, then for this next one, I have x plus 4 equals negative 2. So how do I get x by itself? I get rid of the plus 4. How do I undo addition, I subtract. But I can't just subtract on the one side. I've got to balance it on the other. So the 4's cancel, and I'm left with x alone. -2, take away another 4 is -6. All right. And if you put it back into the question, which I'll do in the next one, you see it does make your left and your right equal to each other. So then now we have 5, so positive 5. If there's no symbol in front, it's positive 5 plus x equals to 9. How do I get rid of positive 5? I subtract 5. But I've got to balance it out. 5's cancel, and I'm left with x equals 4. Now, if we go back into the question, 5 plus 4, if x was 4, equals 9. So we'd have 9 equals 9. They balance out. Right, so you can do a little kind of check for yourself to see if it works. Now for the next one, we have the letter K. We're subtracting 6 from it, and we're getting an answer of 7. So it's saying something minus 6 equals to 7. So we undo the minusing by adding, and we do it on both sides. So -6 plus 6, we have K by itself. 7 plus 6 is 13. And if you think back to the original, it's saying something minus 6 is 7, so it's 13 minus 6 does equal 7. All right, so then now the shorter version is you don't have to show the calculation on both sides. You can if you want. But for this one here, P minus 5 equals -1. Now we know we're supposed to add 5 on the left to get rid of the -5. So you can just go straight to just adding it on the right. If you feel uncomfortable with that, you can show it's -5 plus 5 and plus the 5 there. Then you show your 5's cancel out, and you have -1 plus 5 is positive 4. All right, so it's up to you if you want to show the full method or the shorter method. Just remember, it's always the opposite of what you've got. Addition, you use subtraction on the other side. Subtraction, or a negative number, you use addition on the other side. So here I have positive 4 minus x equals 5. So positive 4, I'd have to minus 4 from it. Now here's a problem. Because x has something directly touching it, it's a -1. It's a multiplication. So we're going to have to deal with that like from the first method. So here my 4's cancel out. I'll be left with -x equals 1, 5 minus 4. And now this is -1x. So I'd have to divide, because I'm multiplying -1 times x because they're touching. Divide both sides by -1. Please be careful, right? You don't change the sign when you are using division or multiplication on either side. The reason that we're changing the sign here, let's say for this example here, okay, we had addition and now we have subtraction. It's because we had to subtract to undo the addition. The opposite of addition is subtraction. The opposite of subtraction is addition. There you have to change whether it's plus or minus, because that's what makes addition. Addition is plussing and subtraction is minusing. We have a negative involved. But with division, if you have 2 divided by 2, okay, we don't suddenly make it 2 divided by -2. Division stays division. Multiplication stays multiplication with the same sign. The only time you work with an opposite sign is addition and subtraction. Please drill that into your heads. Okay, so I've had to divide by -1 here so that I can get my x by itself. Negative and negative cancels with 1 and 1. X is 1 divided by 1 is 1, but positive 1 divided by -1 is negative. Right, that's the only time you interact the positive and negatives, is when you're actually doing the division. But just make sure that whatever you divide on the left, you divide exactly the same on the right. Whatever you multiply on the left, you do the same on the right. Whatever you add on the left, okay, make sure that you're balancing out on the right and vice versa. All right, so just make sure that if you put it back into the question, you're getting back to the correct answer. All right, then 7 equals x plus 2. So here we have, it's 1x, so we don't need to get x by itself. 1x is fine, that's our aim. So x plus 2, how do I undo addition? I subtract. So on the other side, I also have to subtract. Okay, so it looks like we're changing the sign, but it's actually that we are undoing addition from the other side. So 7 minus 2 is 5. My 2's cancel and I'm left with x equals 5. So for the last one here, negative 5 plus x equals 40. So now we know we're going to have to add both sides. So we just make it look like we actually take it across, and when it's on the other side, we use its inverse operation. Okay, it does that in between cancelling step. So this cancelling step, it does that already for us. Okay, so it's up to you which version you want to show. All right. Now there's a mini little exercise. I want you to pause your video and do the exercise and be honest with it. Pause it, do it yourself, and then I'm going to put up the answers for you and explain them to you. Alright, so I hope you paused, and here are the answers. I'm just going to talk you through them. I've done the shortcut method, but I'm going to fill in the longer method as we go along. So it was x plus 10 equals 5. So what's happened is I have done invisible maths. I've taken the 10 over to go with the 5, but instead of addition, I know I need to undo addition with subtraction. So what's happened here in secret, hidden maths, is that it's x plus 10 equals 5. How do I undo addition so I can get x by itself? I subtract 10. Those cancel. But whatever I do on one side, I've got to do it on the other to balance out, like scales. So when you're putting one thing on one side and then on the other side, in order to balance those hanging scales, you've got to make sure that both sides get exactly the same happening to them. So it's going to be x equals 5 minus 10 is negative 5, which takes us back to that. All right, so then for the next one, b minus 1 equals 6. So I've taken the b minus 1, and to get b by itself, I've taken the 1 across, and I now know I need, instead of subtraction, I need addition to undo that subtraction. Again, the hidden maths that's happening is that I have b minus 1 equals 6. I need to add 1 to cancel out my 1, so I need to make sure I balance out and add 1 on the other side. And then 6 plus 1 is 7. So then for number 3, to get p by itself on the right-hand side, I'm going to move that 9 away from the p, but I know in order to move a minus 9 away, I've got to add 9. So I've subtracted 9, so now I'm adding 9. It's invisible on this side because then those cancel. And so we see it on the left-hand side. So we don't need to see that step where you are cancelling out with the variable. But we do need to see the 14 plus 9 bit equals p. So p is 23. Then for number 4, negative 2 plus x equals 8. So we have negative happening. So on the other side we need positive 2. And so 8 plus 2 is 10. So that would have been negative 2. We needed to plus 2 to cancel that out. So it would have been 8 plus the 2 as well. We've put the same thing on both sides. Same thing happening here. The positive 5 becomes negative 5 to balance out and undo the positive 5. And then for number 6, we have 6, which is positive. So we need a negative 6 to undo it on the other side. And then we are left with negative x by itself. But we need x by itself. So we'll have negative x equals to negative 2. How do I get x by itself? It's actually a hidden negative 1. So it's negative 1 divided by negative 1 cancels out. And then in division, we divide the exact same thing on the other side. Don't change the sign. Exact same thing for division and multiplication. So then you have 2 divided by 1 is 2. Here you look at the signs. Negative divided by negative is positive. Okay, but you're still dividing at the bottom with both of the same things. All right, so now going on to the mixed examples. It's the same thing. We're just now putting the addition, subtraction, multiplication all into one. And then moving on, we're going to go to a division type. All right, so the mixed example for number 1 is 2x plus 3 equals 9. Our main aim is that we need to get x by itself there. Right now it has a 2 being multiplied and a 3 being added. In this case, you need to do the opposite of BODMAS. You are first going to get the addition and subtraction away, and then you will do division or multiplication. So first you are taking the constant numbers to one side. That's the addition or subtraction of numbers. Then you are going to get rid of the coefficient. Right, so 2x plus 3 equals 9. So I want to get rid of that 3 first. So if I do it the long method, I'm going to subtract 3 from that side, subtract 3 from the other. That's going to cancel out, and I'm going to be left with 2x equals 6. So at the moment, x is being multiplied. So when a 2 is directly touching a letter, it means they're being multiplied. So I undo multiplication by dividing. But I've got to divide on both sides, same sign. Divided by 2 on both sides. 2 and 2 cancel, so I'm left with x. 6 divided by 2 is 3. All right. Then for the next one, 3x minus 1 equals to 11. So I'm first going to move the negative 1. It's going to become positive to undo and balance on the other side. So I'm undoing the minus 1 and balancing at the same time. So I've got 3x equal to 12. So now we have a multiplication situation here. So I need to divide both sides by 3. Then I have question 3. Still, I'm going to get rid of that positive 3 first, and I'm going to be left with the negative 2x by itself. So when I'm moving across, I need to balance by using the opposite operation. Instead of addition, I'm subtracting now, minusing. Then sort it out, and I'm left with negative 2x equals 12. I need to get x by itself, so I need to divide by its coefficient on both sides. The negative 2's cancel out. 12 divided by 2 is 6. Positive divided by negative is negative. All right, and remember the coefficient is everything that's in front of the x directly touching it. For number 4, we have negative 5y plus 4 equals 19. So I first need to get rid of the addition by subtracting and balancing on the other side. So then I have negative 5y equals 15. So I'm going to divide by negative 5 divided by negative 5. So the negative 5's cancel. 15 divided by 5 is 3. Positive divided by negative is negative. Nearly done with this one. 10x plus 20 equals 60. And remember, if I'm going a bit fast, you can pause it, go back and re-listen to it. You don't have to listen to all of the examples and be confused. Slow down, stop, go back, rewind, and re-listen. So here I have 10x plus 20 equals to 60. So I need to get 10x by itself. Please try and line up your equal signs nicely, as close to on top of each other as possible. It just looks nice. And just while I'm thinking about it, please don't put another equal sign at the front We just need the equal sign where it is in the question. We don't want equal signs at the front and in the middle, just one equal sign. So 10x plus 20, that 20 needs to get subtracted on the other side so that it gets rid of the positive 20 and balances out the equation. So 10x equals 60 minus 20 is 40. I'm going to divide by 10. So x is going to be equal to 4. 40 divided by 10 is 4. Then 6 is equal to, well, negative 4x minus 4 equals 12. So negative 4x, I have a minus 4, so I'm going to have an added 4 on the other side. Negative 4x is then going to equal 16. Divide by this bit in front of the x on both sides. X gets by itself, so we know what x's value is in this question. 16 divided by 4 is 4. Positive divided by negative is negative 4. Then 2x minus 1 equals 2. That's number 87. So 2x, I need to undo this minusing of 1, so I'm going to add 1. So 2x equals 88. I need x by itself, so it's being multiplied. So how do you undo multiplying? You divide. X must be equal to 44. And the aim of this is to find, because x changes depending on the question. X is just representing something we don't know in a question. So in primary school, you used to use a block. It would have been 43 equals 4 block plus 3, and you had to figure out what would work. So instead of a block now, we work with a letter. And each time we're working with a letter or a block, it could represent something else, depending on that question. So the aim is just to see what the x value is, the unknown is in each question. All right, so that's why x changes its value. So at the moment, 4x is being added by 3. So I'm going to take the 3 across. It becomes a subtraction. So that's going to be 43 minus 3 equals 4x. So 40 equals 4x. Divide by 4 to get x by itself. It's being multiplied, so we divide. So x equals 40 divided by 4 is 10. There are 6 more questions now, and these ones are working with division. So we see division happening in questions when we see fractions. Most often you don't see the divide sign, you'll see a fraction. So you need to multiply to undo division. And so if you have a denominator, that is telling you what you need to multiply by. So for the example here, it says 3x divided by 2. So it looks like it's a fraction over 2, but it's actually meaning divided by 2 equals 3. So how do I undo division? I multiply, but I've got to balance it out on both sides. The multiplication cancels out the division. You'll be left with just the 3x, the numerator, is equal to 6. 3 times 2 is 6. Then you'd have to see that we have 3x being multiplied, 3 and x are being multiplied. So how do I get that 3 away? I have to divide. So sometimes you're doing multiple operations in one question. 6 divided by 3 is 2. All right, so if you were to put that back, instead of 3 times x, you said 3 times 2. Because if x is 2, and then divide by 2, let's see, we'd have 3 times 2 is 6, divided by 2, what's 6 divided by 2 is 3, and that was the original part of the question. All right, so I would have gotten you 3. So for this first question, we have x divided by 4 equals 3. So we undo divide by multiplying by the denominator. They cancel, but you have to balance out on the other side. So x must be 12. And think back to the question. Something divided by 4 equals 3. It must be 12 divided by 4 is 3. Then b divided by 5 is equal to negative 10. So if I'm dividing by 5, I can multiply to undo it, but I do it on both sides. So remember, it's not like the addition subtraction, where you have to change from addition to subtraction. It's a plus to a minus. Multiplication and division, they don't have a plus and a minus involved. So you take exactly the same thing on both sides. So if I'm multiplying by 5 on the left, I'm multiplying by 5 on the right, not negative. So b then by itself is equal to negative 10 times 5. So it's negative 10 times positive 5, because we put positive and positive on both sides. So 10 times 5 is 50. The negative that was with the 10 now affects the positive 5 and makes it negative. 2x divided by 3 equals 4. 3 can then be multiplied on both sides to get the numerator by itself. So here you're trying to get the numerator of the fraction, the top of the fraction by itself. Then you can get x by itself. Now it's being multiplied. So when we multiply, we can undo by dividing. So 2 divided by 2 is 1. That goes away. 12 divided by 2 is 6. Last few. We have negative x over 4 equals to 11. So negative x over 4. I want to just get rid of that denominator for now. So times both sides by 4. Those cancel and you get negative x equals to 44. Now we can get that negative 1 away from the x by dividing. And so x is equal to negative 44. Then 2x over 5 minus 1 equals to 7. Remember, always do the opposite of BODMAS here when you're solving equations. We need to get rid of that negative 1 first. So how do I undo subtraction? I'm going to add. So I would have added here and added there on both sides. Those cancel, and so that's why I've just got the plus 1. Then I now have a fraction. I need to get rid of the denominator first. So I'm going to multiply by 5 on both sides. So let's just first fix this. 7 plus 1 is 8 times the 5. And so we have 2x equals 8 times 5. Then the 2 needs to go away. So instead of multiplying, we undo by division. Let's just first, that's going to be 40. Divide by 2 on both sides, x is equal to 20. Last one, and I hope you're understanding this a little bit better now that we are going through each of the examples. Still watch those other videos that have just been taken off YouTube, but these ones are directly attached to your worksheets. And then what I'll do in the next day or so is just put up a video guiding you through the homework exercise as well. Okay, so here is negative 3x over 2 minus 4. So I first got to get rid of that minus 4. Undo subtraction by addition. And then I need to get rid of that denominator. So I'm going to times by 2 to undo division. Those cancel. All right. And then now we've got to get rid of that negative 3 by dividing. Negative 3's cancel. You've got 10 divided by 3. Can't change that. Positive divided by negative is negative. All right, and so if you want, you can put that as a mixed number. Please don't put it as a decimal, though. Either mixed number or the improper fraction, negative 10 over 3. Okay, grade 8. So you can now work on the homework 7.1 and the revision exercise, these questions, if you haven't already. But if you have and now you understand a bit better, you can go back and redo the exercises. So I hope this has helped. Again, tomorrow sometime or the next day, I'll just put up like a walkthrough of how you would work through those questions, and then I'll also just put up at a later point the Unit 9, which is a little bit more challenging with the equations. Okay, so just keep going and keep working as hard as you can.